Lesson 12.7 deals with the effects of outliers. Our essential question, how does an outlier affect the measures of center? An outlier is a value that's much less or much greater than the other values in a data set. An outlier may greatly affect the mean of a data set. This may give a misleading impression of the data. So right here we have, this table shows the number of days that the 24 members of the Garfield Middle School volleyball team were absent from school last year. So most of the pieces of data are between the numbers 3 and 8. But we have this one right here that's 16. That's substantially more than the rest. So why might a dot plot be helpful in determining if there's an outlier? A dot plot makes it easy to see which values are closer together and which values are much less or much more than the other values. So if we go ahead and we plot the data on this dot plot from right here, we end up, you can see all the data is clustered right here between this 3 and this 8. But then there's this one way over here, this 16. This is what you call an outlier. And it kind of skews the data or pulls it away from the center. So the mean should be somewhere around 5, right? Right, somewhere around the middle of all of this data. But instead, it's going to end up being somewhere higher because it got pulled higher by this outlier. And it doesn't give us a realistic impression of the data. Most of it fell here. That's where the mean should be also. Okay, so find any values that are much greater or much less than the other values. Most of the data values are between 3 and 8. The value 16 is much greater than the rest. So 16 is an outlier. So what effect do you think an outlier greater than the other data would have on the mean or the data set? And then justify your answer. So the outlier would make the mean much greater than it would be, than it otherwise would be. It should be somewhere in the middle of all this data, right around there. But instead it's going to be somewhere up here because it's going to get pulled up by this 16. All right. The high temperatures of Foxdale, for a week in Foxdale in degrees Fahrenheit were 43, 43, 45, 42, 26. Ooh, that one's much different. 43 and 45. The mean of the data is 41 degrees Fahrenheit and the median is 43 degrees Fahrenheit. Identify the outlier and describe how the mean and the median are affected by it. So most of the data, once we've made our dot plot, falls right in here between the 42 and the 45. So you would think that the mean, the average number, would be somewhere right about here. But this 26, this outlier, affects it and pulls it down to what, 41? Right there. This is where our mean is. It should be over here somewhere in the middle of all the bulk of the data. But this outlier has affected it and pulled it down. The outlier is 26 degrees Fahrenheit. So now let's find the mean and the median of the temperatures without the outlier. So we're not going to include that 26. So we put all of our values here and we divide by 6 because there's 1, 2, 3, 4, 5, 6 pieces of data. When we add them all up, we get 261 divided by 6, which gives us 43.5, which is right here. That's a more realistic mean. It should be in the middle of the data. So the mean with the outlier, and the median, pardon me, as we work our way in to the middle, are the two 43s there. Then we add them together, divide by 2, and we end up with 43. So the mean with the outlier is 41 degrees Fahrenheit, and the mean without the outlier is 43.5 This is a better mean. It's more representative of the data cluster. The outlier made the mean lower. The median with the outlier is 43 degrees Fahrenheit, and the mean without the outlier is also 43 degrees Fahrenheit. It didn't have any effect on the median or the middle value. All right. Explain why the mean without the outlier could be a better description of the data set than the mean with the outlier. The 6 temperatures were between 42 and 45 degrees Fahrenheit, so the mean without the outlier is in the middle of the week's temperatures, or that cluster of data. The mean with the outlier is lower than all but one of the temperatures. If the outlier had been 59 degrees Fahrenheit, a different outlier, much higher, rather than the 26 degrees Fahrenheit, how would the mean have been affected by the outlier? And explain your reasoning. Well, a 59 degree outlier would have raised the average temperature because it's higher than the rest of the data set. So it would have raised the temperature to be higher than the data cluster. All right, and finally, let's do number 1 on the back page. Find the outlier by drawing a dot plot of the data. So they gave us the data. We drew a dot plot. Clearly this 15 is our outlier, so the outlier is 15. Do the same thing for number 2. Make your own dot plot. So clearly the 68 is our outlier. Find the mean without the outlier, so don't include this 68. And you're going to find that the mean is 98, which is more realistic than the 92. And the median is 98.5, which is pretty close to the mean with the outlier. So it doesn't really affect the median again, but it does affect the mean. All right, good luck with your homework.